All right. Hi, everybody. My name is Attila Segedi. I'm currently with Oracle as a principal member of technical staff in the Java language and tools group, primarily working on Nashorn these days. And this is the concluding talk in the series of talks on various things related to Nashorn at this Java conference. And it will be dealing with how are we actually leveraging InvokedYnamic and how are we using it to implement higher level operations on JavaScript object, and how we are also linking to Java objects as well. You're right. Right. Okay. So we'll be talking a little bit about what InvokedYnamic is. I will talk about the Dynalink, which is a higher level dynamic linking framework on the JVM that I develop, and I will talk specifically about how did we integrate Dynalink into Nashorn. This talk is primarily of interest to people that either implement a language runtime on the JVM. Quick show of hands, who's doing that? All right. And alternatively, to people who are interested in how it's done, which is hopefully the rest of you. All right, so what's InvokedYnamic and how did we actually manage to implement dynamic languages before we had it? What we did is that in a hypothetical situation, and I'll have some code on the slide, so if you don't see it well, you're welcome to move forward. We had this hypothetical situation where you have a dynamic language expression where you need to print the color of an object. You want to retrieve a property. So for instance, back in the days in, say, in Rhino, you would have a static helper named getProperty. You pass the object to and you pass the name of the property that you want. And this gets compiled roughly to this sequence of bytecode, which is load the object, load a string, invoke the static method. All right, so that's what we had. Now, the get property itself might be implemented something like this, where you are doing a lot of things, but most notably, you end up invoking a get method on an object with, there's the start parameter for various prototype resolutions and whatnot. And for instance, for a native scripting object, this might end up being a retrieval of a slot or some map. So JavaScript objects are basically just associative dictionaries. So they look like a map and they walk like a map. So they're pretty much a map. And if you have an integration with a Java object, you might have a wrapper around the Java object where you would do some reflective discovery of your getter, maybe a field, maybe a method name gets something, and then you invoke it. And this invocation then is again reflective. So what's the problem with this approach? The problem is that you end up with megamorphic code paths. There's no way to optimize for that. So every reflective method invocation to Java will go through this code regardless of what class that is. There's no way for Hotspot to optimize this thing. It defeats inlining every other optimization. All right. So how does InvokedYnamic changes things for us? Now, instead of having to go to any kind of a helper, you can just use your InvokedYnamic instruction, and you can specify your operation here, which is a get the property named color on something that's an object, and I will get back an object. Especially in a highly dynamic language like a JavaScript, you have no idea what will you get back and what you're passing, so your signatures usually end up quite generic. If your language is such that you can infer types at compilation time, these might be more specific, but generally these are not the case. And you also need to use something that's named a Bootstrap method, which if you ever heard a talk about method handles and InvokedYnamic, you know what it is. Won't go too deeply into it. Basically, it's a method that returns you something named a CallSite, which is the runtime reification of that particular InvokedYnamic instruction, and it tells the virtual machine that, hey, okay, at this point, I will return you an object that is a holder for a function pointer. As I said, the CallSite it holds a method handle. Method handles are basically anonymous function pointers, except that they're safe. And the Bootstrap method needs to return a call site that's somehow bound to a method handle. And when the JVM gets to the execution to the point where this invoke dynamic instruction is, it will invoke whatever method is currently linked into that call site. Some call sites are immutable. When you create it, you link it to a method handle, and it always stays linked to that one. And you also have the Java platform provides you mutable call sites that you can change the linkage to them any number of times. And these are the really interesting ones for us. The difference between method handles and reflective methods, in case you wonder, is that reflective methods, they always correspond one-to-one to a Java method. So if you have a method foo on a class, you can take a reflective method to that. You can get a reflection method object that represents that method. On the other hand, method handles are, John Rose just said in another talk preceding mine, they are functional programming basically on the JVM, because you can combine them. You can build combinations of them that are basically if statements. You can do folding, binding of arguments, permutation of arguments, all other kinds of things. And the nice thing about them, they can get inlined, and they are not megamorphic, so we supposedly get a much better performance than using the previous approach. So as I think Charlie Nutter said once that invoke dynamic is neither invoke nor dynamic, and that's true. It's really a way for applications to govern their own linkage. So if you have a call site, normal JVM linking rules where the instructions invoke virtual, mostly the invoke virtual and invoke interface, they will specify, I want this call to link to a call in this class, method named this, with a signature this. And there is a whole set of rules in the JVM specification that tells you how will the JVM find the target class, doing virtual dispatch if it needs to, find the target class, find the method in it, and call into it. Obviously, a linkage happens there as well. Invoke dynamic is basically a way for your applications to use any linkage they want. They can govern their own linkage. They can specify that at this point in a call, I want to determine what method gets called. All right. Small digression is, let's consider what is a property on an object. Here we have two examples. I will probably be going with this object.color example for most of the talk. It's very simple to understand, and it demonstrates most of the concepts. So you can have a class that has a public field, right? You could consider that that public field is something that can reasonably be expected to be addressed when you say object.color, right? Or you can have a class that has a private field and has a method named getColor that corresponds to the beans, property getter naming conventions. Or you can even have something completely wild as a class that implements a marker interface, unconventional API, that will tell it that, hey, I will be using some completely different naming scheme for my methods, and maybe it will be using get underscore and no capitalization. And again, it should still, when you say object.color, the runtime should still be able to somehow figure this out. So, and what if you have crazy code like this, where you take an array that has an instance of the first class with a public field, another class with a bean getter, and a third class with the unconventional getter, and then you run in a loop, and you want to retrieve the color property on all of them. Right? So your loop body, what it gets compiled to is, and we want to concentrate on this line, there is some other things, as in you can dynamically invoke the printline function, and you have a dynamic invocation, the dynamic retrieval of the indexed element of a collection as well. But here, this call site, it needs to be linked to 3 different getters. It needs to be able to dispatch to 3 different getters as those objects are encountered transparently. Oh yeah, something about the println. If it's actually an instance of a function that goes back to a print stream println, probably one retrieve that system out, then which overload of println does need to be invoked here, right? Or what happens when you want to invoke a variable argument function? Here's the thing. InvokeDynamic does not give you these kinds of high-level operations. InvokeDynamic only gives you the ability to specify what method do you want to link, but it doesn't help you with actually finding the appropriate method that you want to link in a particular situation. So if you have any of these questions when you're implementing your language runtime, how do you get or set properties on an object? How do you invoke a function? How do you retrieve elements? How do you invoke a constructor? Then these are all things that InvokeDynamic as such on its own won't help you with. Or, again, you need to retarget your CallSite for a previously unseen kind of object. And you have all scenarios for multiple dispatch. Java overloaded methods are a prime example of multiple dispatch. So, yes, when you are implementing your language runtime, you will have a Bootstrap method. And it's great that the JVM gives you an ability to write a Bootstrap method that will decide what gets linked into your CallSite. But what do you put in it anyway, right? What is it that you will actually put into your Bootstrap method? So these high-level operations, this is what we normally refer to as a Metaobject Protocol. So all these high-level kind of operations, getting a property, setting a property, everything that I had on 2 slides before. InvokeDynamic is not a Metaobject Protocol. It stops short of being a Metaobject Protocol. It is, however, a very good low-level infrastructure for actually building one. This is where Dynalink comes in. Dynalink is an open source library that I started developing before I joined Oracle and that I keep developing with the same conditions, Apache licensed, independently open sourced after I joined Oracle. And Dynalink, Nashorn uses Dynalink for all of its dynamic linkage right now, both to its own objects and to Java objects. It is basically a library that gives you the what goes here part in your Bootstrap methods. And it already ships with a linker for plain Java objects in general. And it, because every JVM language will want this, maybe not. But it's hard to imagine a language running on the JVM wanting to benefit from the JVM ecosystem, from the class libraries that you have there, that will not want to have integration with plain Java objects, ability to call them, manipulate them, handle them. And this library basically solves all of these problems for you. So the question, what do I put in my Bootstrap method? The answer, if you use Dynalink, is you have something called the dynamic linker factory, which you use to create a linker, and afterwards you do have this dynamic linker. And this actually looks a little bit scary, but all it is you get your linker, you invoke its link method, you create a CallSite, which can be any CallSite really. We ship with something that's called a chained CallSite, which does a really good caching of, it's basically a polymorphic inline cache as such. And this is some administrivia that you don't really need to worry about right now. It is, at the end of the day, this is a single statement. That's all you need at this point. What it does is it will take your CallSite and it will link it to a special method handle that does nothing at all. It does not know at this point what needs to be invoked. It will link to a special method handle that when it's invoked with actual arguments, it will know how to relink the CallSite for those actual arguments. So going back to our example with the getting the property color from three different classes with 3 different conventions for how is something named color determined on them. What Dynalink does is it has a way to discover different linkers that are available in the class path. It's actually using the meta-inf services mechanism where the various jar files with language runtimes can declare that, hey, I have a linker for my language. So ideally, you will have, if you're using JavaScript, Nashorn, you will have a Nashorn linker and then you will have something for that unconventional API which knows how to retrieve a get_color when it's when you require color from it. And you also have a beans linker, which is something that is part of Dynalink. That's the fallback linker that you normally include, and when any other linker doesn't know how to handle an object, then you just fall back to the beans linker and it just gets treated as a POJO. So when getPropColor gets invoked on a class 3, which was this unconventional API, unconventional linker will say, hey, I know what to do with this guy, and it will return back a method handler that's a composition of a test saying, as long as it's basically a guard that determines the validity of the operation. It says, as long as what you will be passing here is an instance of class 3, this is what you need to do. So this is a pair of method handles. One returns a Boolean, which is a test for the validity of the operation, and the other is the actual operation. And then the CallSite, sorry, question?
Yeah. Is class 3 or is the tag interface that you said before called unconventional API?
You would use instance of class 3 because you need to cast to class 3 because you don't have a method get_color on the unconventional API. Imagine it as just being a marker.
So you need to have an unconventional linker for all classes?
Unconventional. If you are publishing classes, you have a language runtime and it creates a classes that conform to some kind of an Metaobject Protocol, some kind of an object model that is not the exact Java object model, right? Then you need to have your linker. But you usually can have one linker for every class that's published by your runtime because your runtime will normally just follow a single non-standard object model. If your language runtime is just following the standard object model, you don't even need any of this because then beans linker has you covered. All right. What then happens is that the CallSite itself will take these two and it will compose them into a so-called guard with test method handle, which says, if this is true, then do this. If this is false, then go back and relink, right? So on the next iteration of the loop, we might get an instance of class 1. I know this is not the same ordering that I was using in the original slide. I had class 1, class 2, class 3 there, but you get the idea. So in that case, for class 1, there is no specific linker. So what we get is, yes, as long as the beans linker will say, as long as what I'm passed is actually of class 1, and notice there's not actually instance of, I will cast it and I will return the field. The reason we could use instance of in the previous example is that we were invoking a method with no arguments, which cannot be overridden in a subclass. Well, even if it is, it's not about overriding. Even if it is, you get virtual dispatch to the override, but you cannot overload it with variability. But if you are going to a field, then you need to have exact class matching. So what happens in the next step is that we had this part. And now the CallSite will again recompose it into this cascading set of tests saying, all right, if what I got is of class 1, then I will invoke this. If I didn't, I'll see whether I get a class 3, then I will invoke this. Otherwise, again, go and relink. And then on a third iteration, you get the idea. This will also be handled by beans linker. And it will say, okay, the class 2, it doesn't have a public field, but it does have a conforming beans conforming getter. I will return you a recipe for linking, saying as long as what you get is instance of class 2, cast it to that, invoke the getColor function. And then it again gets linked as a cascade. So at this point, your CallSite is actually linked into 1, 2, 3, 4, 5, 6, 7 method handles that are composed into these nested if blocks, which in method handle parlance we call the guard with test combinator. So this is, in a nutshell, this is how it works.
So how well is that inlined?
That's not a question. The question was, how well is that inlined? The answer is, none of my business, really. That's an excellent question to be asked from the JVM compiler people. Yeah. So, what properties do we support? Sorry, what operations do we support right now? We have a property getter, a property setter, an operation for getting and setting elements of a container, which are typically arrays, lists, and maps, directly invoking a named method on an object, invoking something that serves as a constructor. If we have a first-class function object, then we can just call it. And honestly, we can just expand the list of these operations as we need, because they are just string constants in invokedynamic instructions, and there is not even any kind of an Java interface or anything that it can conform with. So expanding the set of these operations is easy. We will be adding as we identify the need for them. Probably in the near future, we'll add support for iterations, for iteration over container elements, properties, and so on. And there is also an interesting thing that I just recently did, which is support for so-called combined operations. So in a single invokedynamic call, you can say, I want to retrieve either an element or a property. This comes into play when you have a language like JavaScript, in which basically an object.foo is a property accessor, but JavaScript doesn't have a separate namespace for properties and for elements of a container. So if you're maybe addressing a Java util map, when you say map.empty, are you now addressing the isEmpty property getter, or do I actually trying to retrieve an element of the map with the key empty, right? By letting the language runtimes specify that at a particular call site, you can request more than one operation, and it's the job of the linker to figure out which one is appropriate at that point. You can resolve these ambiguities. In JavaScript, we can do that. If you are using the dot operator, then we will ask for a composite operation of get property, then get element if there's no such property. And if you're using the square bracket notation, then you can say get element. If there's no element, then get the property. And that resolves most of the ambiguity. As I said, we have a beans linker, which is the fallback linker for everything that's not recognized by any other linker. And it provides you element access for arrays, lists, and maps, full method, field, and property access on Java objects, and on special objects that are exposed as the static, I call it the static facet of the application. I'm not using the JavaLang class object as the static facet of the application. Rather, we have a separate representation for something that can be invoked as a constructor and that exposes the static methods. Completely handles all the overloaded and variability methods. These are notoriously hard to get right, so this I usually pitch this as the biggest selling point of the library. Normally, if you have your own language runtime, you will need to write a linker. There is an interface for that. It's named guarding dynamic linker. It's a long name, but it's guarding because you normally specify two linkages, two methods in a linkage, a guard and an actual method, as I show you. And it's dynamic because it runs very late in the invocation process. Basically, it runs for the first time a particular invokedynamic instruction is called with that object type at that call site not yet having been seen. And, well, duh, it's a linker. You will just need to work with, so you need to implement this interface. You will need to return instances of this type named guarded invocation, which has the invocation and the guard, and also a switch point, which you can use for asynchronous invalidation of the call sites, which is sometimes a nice thing to do, because you can get more optimal linkages. And whenever you're invoked, you will have to deal with an object of the type link request, which will describe for you what's the name of the operation at the call site, what are the types there, and what actual arguments did you receive at the invocation. So your linker is invoked, it kicks in at the first invocation, so you do have the actual arguments that the function, that the method at the call site is being invoked with at that point. There's an important distinction between a linker and a call site. Linkers produce the guard and invocation method handles. They don't compose them into this guard with test. So they are returning a pair of method handles back to the underlying machinery. And eventually the call site itself receives them and it decides how to compose them. I showed you the chained call site will do this chaining of guard with tests, basically this cascade. But you can have a really simplistic one, which was we just always installs the latest one that it got and relinks in every other case. That pretty much gives you a monomorphic inline cache at that point. This is the right design because linker decides what is linked and the call site decides how it's linked. And since the call site always resides in the code that you generated in your language runtime, you always control how it is linked. But you might need to link to, a POJO or something, so you don't know what needs to be linked, but still in your target language runtime where you emit the call sites, you get to decide how it is linked. We support all the method invocation conversions as specified by the JLS. If your language has additional conversions, there's a place to plug those in the framework as well. You can have your type converter factories, which produce, again, usually guard with test converters saying, hey, as long as I got an instance of my special object and it needs to be converted to string because my language, in its infinite wisdom, actually supports conversion of arbitrary objects to strings, then here's a method handle that does it. And you will also need another interesting little interface, which we call the conversion comparator, which we had to add because, at least with Nashorn, JavaScript is such a good proving ground because it's the most highly dynamic language you can imagine. So you pretty much have an implicit conversion from anything to everything, right? And so we were running into, as soon as we started allowing more type conversions, we started running into very wide ambiguities when you had to choose an overloaded method among several overloads when you were linking to a POJO overloaded method set. And for that, we introduced conversion comparator, which can augment the Java language specification overload resolution rules to make sure that you can it basically compensates for your ambiguity in allowing more type conversions. Yeah, that's not too important. So, in summary, Dynalink, we use it in Nashorn. There is quite wide interest to be used in other projects within Oracle as well, where languages are being implemented. It's Apache licensed open source. You can get it at this URL. I'm publishing binaries to Maven Central Repository. I'm publishing snapshots as I go, so you can always just grab it and use it. Which brings us to the final topic, as in how do we use Dynalink in Nashorn? So, in short, Nashorn uses Dynalink for all of its dynamic linking. That's the way this library is intended to be used. You don't have a separate code path for your native objects and they say, oh, and I will just use Dynalink for everything else. Rather, you just go through Dynalink for everything. We did get some interesting use cases that came up. First one was that, remember that slide when I told you what comes in here? And I told you that, oh yeah, you can just do a new dynamic linker factory and you can create a linker and off to the races. Well, if you have your own language, this gets a little bit more complicated. So you will instantiate your factory, but you will then be setting several linkers in it. And as you can see, there's this nice method saying set prioritize linkers, set fallback linkers. Prioritized linkers are a Nashorn linker and the Nashorn primitive linker. Wait, we need two? Yes, we do. I'll explain. There are also fallback linkers, which I told you that when you normally cannot link anything, you don't know how to link it, then you just fall back to a beans linker. However, we also ended up having a Nashorn bottom linker. So instead, you would expect that normally in a language runtime you will have a linker for the language runtime and a fallback to a beans linker. We ended up with two others. And this seems to be a pattern that will probably be valid for many other languages too. And then you create a linker and then, yes, you're off to races. So many linkers, right? What do they do? The Nashorn linker links our script object, which is an abstract class that all the Nashorn JavaScript classes subclass from. It also links undefined, which is a special value type in JavaScript that specifies a value that was not defined. Nashorn primitive linker, on the other hand, it links strings, boolean, number, and a static class, which I won't go into. But you recognize these, right? These are your typical Java boxed types for Boolean, for arbitrary number, and yes, the Java string. Now these values are actually being used as primitives in JavaScript. Then we have something that's called auto-discovered linkers. All other linkers that are in the class will that are in class paths will come here. And then we have a beans linker to link the Java objects. And finally, we have the bottom linker because we have something that even the beans linker falls through for some cases. Namely, what happens if you want to link a function call on null, right? You want to call null in JavaScript, you can try to. It should fail. Missing property operations and some other things. So it's a lot of linkers, but this is okay and this is expected. Most of the linkers can implement an additional interface named type-based guarding dynamic linker, which has an additional method that the framework can interrogate for, hey, can you link a class of this type? So normally we bind a linker to a class and a class value, so the dispatch is fast. So even if you have a lot of linkers floating around your runtime, it's fine because in most cases you can just dispatch based on the class and it's really, really fast. As I said, we have some, yeah, question?
Is the linker used to handle the JS adapter that you mentioned with the get and put methods?
Is the linker used to handle a JS adapter? Define JS adapter?
In the Nashorn talk, you mentioned you pass a JS adapter object.
JS adapters are native script objects. So yes, it is used. The Nashorn linker will be linking it. Yep. Okay, so why do we have this separate primitive linker for a string, Boolean, and number? Now, here's the architectural background for that. For one thing, we don't want them to fall back to beans linker because we are having special semantics for them within the JavaScript runtime. You can do things like you can take a Boolean false and you can invoke a method on it, right? You can. So we don't want them to fall through to the beans linker. So we need to have something that catches them before. On the other hand, we don't want this semantics to escape outside of our runtime, and the Nashorn linker itself is exported, so other language runtimes can discover the Nashorn linker for cross-language interoperability. But so what we have is we export the Nashorn linker to be visible through meta-inf services, but we don't export the Nashorn primitive linker. So it's a separate linker, additional semantics, but it's private to our runtime. This is a technique that's eminently applicable to any other language runtime too. Why do we have a separate bottom linker? Well, as I said, again, we have these corner cases. We have no op getters, setters for non-existent properties, and we need to throw a bunch of type errors when you try to use a Java object as a JavaScript constructor. You cannot do that. We try to invoke a non-existent method on a Java object. You try to invoke an operation on null, things like that. We also have a separate thing where we intercept the new operation, which is normally just either handled by if we get in a Nashorn linker a new operation or script function, we know that it's a constructor invocation of a function in a JavaScript. But if we get a new invocation on a Java interface that happens to be a single abstract method interface, then well, in JavaScript you can use this syntax where you say, well, you cannot use it in JavaScript, but conventionally the JavaScript implementations on the JVM, Rhino, will allow you this syntax where you say new runnable, and it's a Java runnable, and then you pass some JavaScript function as a constructor argument. And you know instinctively what this needs to be, right? You want a new adapter, Java class that implements the runnable interface, and when its run method is invoked, it delegates to the function. Now, obviously, beans linker cannot handle this because beans linker knows nothing about JavaScript functions. And it needs to be somewhere. So again, our primitive linker intercepts these. And if you are having a non-sem type, then our new will just fall back to beans linker and link with whatever. So you can say new Java util timer task, and it will just go down to the beans linker. That's a trick, actually, because it's an abstract method, but we happen to handle those too. one other thing that you want to do is throughout Dynalink we use something that's called a CallSite descriptor. You can think about, I told you, a CallSite is mutable, usually. You can relink it. And when we are passing things around linkers, we don't want linkers to even accidentally just think about relinking the CallSite. So we don't ever pass them the CallSite. They don't see the CallSite. What they see is a CallSite descriptor object, which is an immutable object that contains the name of the invocation at the CallSite, so dyn get prop color, signature of the CallSite, and the MethodHandle's lookup object that was used at that point, which usually is the public one for dynamic languages, but it can be a specific one if you want to deal with access to protected members from a subclass. However, we don't have that in Nashorn. We do have a default implementation of a CallSite descriptor in Dynalink, which again can be used by any language runtime. Interestingly, Nashorn does not actually use it. There's a reason for that. Because we need to have a language runtime specific arguments in our CallSites, we actually carry an int there. And that int contains a bunch of flags, whether the invocation is for a scope, whether we have tracing and profiling set on, and more importantly, whether at that particular CallSite we are using the strict mode invocation semantics of JavaScript. And these are interest only to Nashorn. So you need to be careful when you are writing your code, because other language runtimes, if they ever receive a Nashorn CallSite descriptor, a beans linker can always receive it, right? Because we are invoking something from Nashorn and it happens to be a POJO. It falls down to the beans linker. The beans linker will get the Nashorn CallSite descriptor. Fortunately, it is an instance of plain old CallSite descriptor. It's actually an interface. So other language runtimes can use it. They have no knowledge about these additional flags, and it's right that they don't, because they couldn't do anything with it. There's no semantics for them there. Some discipline is required when you're doing this, because Nashorn linker itself cannot assume it will always receive one of these, since it's an exported linker. So you can get into a situation where you have maybe a Python or a Ruby implementation that uses Dynalink, and sometimes you will get a request in a Nashorn linker to, maybe your Ruby runtime will get a Nashorn object, and the Ruby runtime will need to link to an operation on that Nashorn object, and it will pass it its own Ruby CallSite descriptor. So publicly exposed linkers, they cannot make an assumption that they always get their native CallSite descriptors. They have to be prepared to play nicely with foreign ones. So we have static helpers that extract that bit field and then just fall back and assume it's 0 if they get some kind of a call descriptor that they don't recognize. On the other hand, Nashorn primitive and bottom linkers, since they are never exported, they can just go wild and cast to Nashorn CallSite descriptor, because since they are never exported, they will always receive that. And they actually, it's better if they rely that they do, because if we cast and we fail, then there's a bug in our linker implementation, so we need to do something about it. Yeah, so this is pretty much the way we implement this is a get flags will say, hey, is that CallSite descriptor instance of Nashorn CallSite descriptor? Yes, it is. Cast, get the flags, otherwise assume 0. And then a request say for, hey, is it a scope invocation? We'll do an isFlags CallSite, which will do an isFlag, which will basically delegate back to here, to this isFlag, which does the get flags. And so this is the graceful fallback. So if you are faced with a foreign one, you will always just go back. And this is how Nashorn linkers accessible code checks for scope. It uses the static helper. Code that's only accessible from Nashorn primitive linker, it doesn't do anything of the source. It just blindly casts because it's an assertion that it should be able to do so. Type conversions. I think this is our last topic. Both Nashorn linker and Nashorn primitive linker have implementations for type conversions. Nashorn linker will be converting script object to strings, numbers, booleans, and single abstract method interface types. They can convert string, number, and boolean to each other, because that's something that you need to be able to do in JavaScript. And we actually had to do cross-boxing. We have a really, really good test suite that shook out all of these things. Nashorn does have thanks to Marcus' work, has ever better internal type optimizations. So sometimes you will end up with, you just don't assume, as you could theoretically in JavaScript, that all of your numbers are always doubles. With us, they are not always doubles, but they are still sometimes boxed. So you legitimately can find yourself in a situation when you need to have a conversion between uppercase I integer and uppercase D double, which, again, this is something that the JLS does not provide you. As I said, Dynalink gives you all the JLS specific type conversions. This was something that we had to build on top of it. And I don't intend to put it in a lower level into Dynalink because it doesn't have any place there. This is entirely JavaScript implementation specific, this kind of a cross-boxing. And of course, as I said, we have the conversion comparator interface that prioritizes conversions, because that was also an interesting test case failure when you said, all right, new thread, new runnable something. And at first, you get an ambiguity because in JavaScript, anything can be converted to a string. So it said, okay, well, you know, both thread string and thread runnable apply at this point, and according to the JLS resolution rules, neither is more specific than the other one, so this is a linkage time error. Now, obviously, you know, we all know what we want. We want this guy to get invoked. So our conversion comparator augments the JLS rules and specifically says, if you're faced with if there is an object and you have to choose between a string and some interface, and the object happens to implement the interface, then go for that. You have some exotic things like if you have a Java function, overloaded method, and one takes a string, another takes a Boolean, and from JavaScript you invoke it with 1. Well, what do you do? Again, you could just throw an error, but which actually might be a sensible thing to do, but what if this poor programmer is not actually aware of the fact that or maybe this is not a literal one, maybe it just manifested itself as a result of a calculation, right? And there's a number, there's a Java object, I need to invoke a method on the Java object with that name, and I only have a string and a Boolean version. Which one do I call? So right now what we do, I believe, is that I will prioritize string over Boolean with the heuristics that it's less amenable to information loss, because a 1 can have a representation as a string. Well, 1 can have a representation as a Boolean as well, right? But what if it weren't 1? What if it were 42, right? So you can convert it to a string so that if you inspect it, you still can realize that it maybe was a number and it's still a number, and you cannot do the same with a Boolean. Now, the nice thing about all of this is that you just need to implement a conversion comparator interface, which is really simple. It says, it takes 3 classes. It says, I have an integer, and I have a candidates that are string and a Boolean. Which one should I choose? That's what you implement, a method that answers this question, and it plugs into the overloaded method resolution machinery that lies underneath, and just works. Dynalink gives you that. Sometimes you want to use type converters outside of linking. We have a solution for that too. There is a dynamic linker, has a method on it that is named getTypeConverter, and you specify a source type and a target type, and you get a MethodHandle that, when invoked with an object of the source type, gives you an object of the destination type. We specifically use it to convert JavaScript arrays to Java arrays. We don't have this as an implicit conversion because we are not forced to. Fortunately, this is outside of the scope of the the JavaScript specification. But we do have an API named capital-Java.sJavaArray. And then you can take a JavaScript array and say, I really need this thing to be converted into a Java array of strings. And then what we do is we get a type converter, usually from object to string, and just run it through every element of the array. The nice thing about it is that for whatever reason, you maybe got some foreign thing, maybe some Ruby or Python object stuck into your array, then this kind of a conversion will actually find the appropriate conversion of a Ruby object to string and make sure to invoke that too. Well, these are the interesting use cases that we found as we were actually integrating Dynalink into Nashorn. As I said, InvokeDynamic is a start, but it's not a Metaobject protocol. Dynalink is a framework for implementing Metaobject protocols, and it ships with a standard Metaobject protocol for POJOs that you can use as your fallback. And additionally, you can just additionally, you will need to implement the object model for your own language runtime for it to be a full-blown usable something in your language. As we could see, your language runtime's requirements can drive some interestingly elaborate architectures. We can have multiple linkers. We can have custom CallSite descriptors with language-specific flags in them. You might need language-specific type conversions. Some of them are public, that is exposed. Some of them are private to your language runtime semantics. You can have some extension of Java semantics for single abstract method interface constructors. These are all things that you will be faced with when you are implementing a language runtime and using Dynalink. But this is to be expected. This is part of the integration effort. You will need to solve these problems even if you don't use Dynalink, so you might as well. All right, that's all I had. I think we still have time for questions. Yes? All right, the question is that the real benefits of Dynalink will seem to be realized when every language runtime starts using this, and then we have actual cross-language communication in a single JVM. And what are we doing to get other language implementers to start using it? Well, I'm evangelizing it whenever I can. I'm talking about it left and right, and probably being even a little bit annoying with it. Over the course of first version of this library, I was presenting at the 2008 JVM Language Summit. At that time, we didn't have InvokeDynamic yet, so it was a purely library-based solution. The InvokeDynamic version is something I started hacking up on a vacation in 2009, and I showed it at the 2009 JVM Language Summit, and we had JRuby guys, Jython guys, other guys there. I presented it. I presented it again on 2011 JVM Language Summit. Charlie Nutter specifically, he's always really, really enthusiastic about it. It's, yeah, I guess I need to grab him sooner or later. I don't see that he adopted it yet. I think he should. I think he himself thinks he should. He's probably, I don't know. I don't want to second guess Charlie, okay? But as far as I'm concerned, yes, I'm talking about it to language implementers whenever I meet them. That's what I do. And hopefully the fact that, yes, we do now have it proven as working in Nashorn is probably additional credibility to it. It is an independent open source project on GitHub, so it can be adopted. We will see going forward where it will end up. I don't want to say anything with regard to its future fate. It sort of seems reasonable for it to eventually get part of the standard JDK, but again, as I said, actually I can talk about anything because I show you my safe harbor slide that says that I can. That anything that I said can not be taken seriously, but but yeah, the overall idea is that just by making sure that it's ubiquitous, available in multiple places, and it just needs to gain traction. It gained, I think, a significant foothold with Nashorn, and hopefully this will continue.
The thing is that both motivating the language writers to use it. So the people who are using InvokeDynamic, it's obvious that it resolves all the Java call issues, calling POJOs and whatnot. But say the Scala guys who typically would not be using InvokeDynamic, we have to convince them to be able to write things so that other languages can look at their type of objects. So it's a motivation of the language writers.
Right. Scala specifically, I think in 2.9, they introduced their own, some kind of a facility for dynamic invocation, but it's funny because it's, you need to have a static interface that declares that the object is dynamic in order to call. I think that's how it works. It's, I don't know the specifics, haven't looked into it. Yes?
Part of the program, it seems like for a language design, every meta-object like construct needs to expose from this Dynalink. Like, I mean, looking at the current list of the things we have, I can see that it does have everything for JavaScript, but imagine if I think of what I need, let's say, really, or if some things like the operator overload and so on.
Mm-hmm.
Adding those stuff, and you end up with like the union of all the possible scripting languages in the world that you can transfer as a control. Like, so it seems like there's some tension between trying to include multiple scripting languages in here versus maintaining a complete
Okay, so if I understand the question correctly, it is basically, it's not so much a question, it's an expression of a worry that if we need to incorporate all the operations possible on objects coming from every language runtime that's out there, we will end up with a really, really big operation surface, that the number of operations that we have will be very large. Well, that's one way to think about it. Another way to think about it is that, for one thing, you don't have to expose every operation. I was very careful for all the common operations, I always use the prefix named dyn. So it's dyn, colon, get prop, whatever. If you have your language and you need to want to go through the linker in every case, but you don't necessarily, you might have some private operation. You can just use your language prefix as the operation schema, basically, and run with it. So you don't need to expose all the operations necessarily. On the other hand, the intent here is that we want to identify wide, usable subset of operations that are common to many languages on the JVM. I mean, yes, I mean, it cannot really be an idealistic, you cannot really have an idealistic view here because then you really end up with an unmanageable size for everything. But I'm saying that we definitely can have a pragmatic subset that still allows meaningful interoperability in a majority of cases that you would want to. But you're right. And as far as adding operations, I am very open to suggestions to how incorporate things like operator overloading and so on and so on. It's just that I don't have the bandwidth to start writing the Ruby linker and see what things will it need as a support. But if somebody starts to do it, I will be really happy to cooperate with them and see where we can get. So yes, I'm aware that there are still unidentified requirements and needs here. And I am actually very careful to not end up with something that is specifically JavaScript shaped. so that's something that I'm paying attention to. Just the fact that you have a separation of the element of a container and a property and actually method right now, and I'm not lumping those into a single namespace, right, is something that I wouldn't have to do if I only targeted JavaScript. But since I'm targeting a wider number of languages, I try to make sure that I maintain a high fidelity API or high definition or whatever you would want to call it. Yes?
Do you see any benefit in making the heuristics more declarative rather than hard-coded? So to be able to basically, do all different linkage strategies and type conversions by a set of rules instead of hard-coding it in library?
Well, it's not hard-coded in library. You can write your own linkers, and those linkers are consulted when something needs to be linked. So the question was whether I see any benefits in having a more declarative set of rules and strategies for linkage instead of it being hard-coded. Right now, the thing that you could say is hard-coded is the beans linker, which I ship, but it is meant to, because it implements the beans protocol for accessing Java objects. You can override it though, because we already override it. When we use our Nashorn primitive linker, we will treat the JavaLang Boolean, JavaLang string, and everything that's a JavaLang number. We will treat it separately. So if you put a linker in your chain that comes before your beans linker, you can override any functionality in there. So this kind of flexibility is something that you already have. Yes?
Is the bean linker coping with those non-Java bean invocations that are spread out on the JDK, like, for example, collection size, or, there are a few classes, for example, in NIO that do not have to get property thing or keys, stuff like that?
No, it's not. So, well, yeah, of course, you can have a plugin for everything. So the question is whether the beans linker copes with non-bean conformant method names, as in collections have a size method instead of get size, and maps will have keys instead of get keys, and so on. The answer is no, these are not exposed as property getters. They are exposed as methods, so you can still do list.size braces to invoke it.
But you got to know what you're looking for, so you need some sort of annotation, as apparently, I think it was Josh Block actually, who went off the naming conventions in the JDK key set and size and stuff. So in order to rectify that, you need some kind of annotation for them to, like, in the general case.
Right. Yeah. So they will, as I said, they will still be exposed as methods that you can invoke. So you can use the call verb in the Dynalink to invoke them as methods. So in your source language, you will actually need to say, you will need to use the method invocation syntax instead of the property access syntax for those.
Right. Or another option could be to add a linker before the beans linker that actually copes with this JDK.
Yes. You're getting the gist of it. That's pretty much what you can do if you want to.
When Nashorn is public, there'll be a couple examples of specialized linkers. Things like for map, as an example.
Oh yeah, we actually have somebody in house who is. I was pleasantly surprised because he's having a lot of fun actually writing additional linkers for things. It's like special linker for maps that happens to expose these, and a special linker for JS object, those Netscape specific JavaScript APIs that are reflected into Java when you're using applets from a browser, or I think he was also writing a linker for XML DOM objects as well, which is again something that you can do. So he's having so we'll have those as examples. All right. Any more questions? Going, gone. All right. Thank you.